In this lesson, we will examine a type of factoring called difference of squares factoring. To learn more about this technique, we will first make some observations. Let's see what happens when we multiply two binomials where the binomials are identical except one binomial has a plus sign and the other binomial has a minus sign. To expand these products, we will use the FOIL method. So for the first product, we will multiply the first terms to get x squared. When we multiply the outer terms, we get negative 3x. When we multiply the inner terms, we get positive 3x. And when we multiply the last terms, we get negative 9. At this point, when we simplify, we can see that the two like terms, negative 3x and positive 3x, cancel out, and we are left with x squared minus 9. In the next example, when we apply the FOIL method, we get the following. When we simplify, we can see that negative 10x and positive 10x cancel out, leaving us with 4x squared minus 25. One more example. Applying the FOIL method here gives us this. When we simplify, the two middle terms cancel out to give us 49x to the power of 4 minus 1. Please notice that when we expanded and simplified each of these products, the first term is a square, the last term is a square, and in all three cases we are subtracting one term from the other. In other words, each result is a difference of squares. From these examples, we can say that the generic product a plus b times a minus b will always equal a squared minus b squared. Given this rule, we can expand this product by first taking 3m and squaring it to get 9m squared, and then we will take 2y and square it to get 4y squared. From here, we can take this result and use it to help us factor expressions. To do this, you may find it useful if we reverse the order of this equation. Okay, now let's say we want to factor x squared minus 16. We should recognize that we have a difference of squares here, since x squared is a square since it is equal to x squared, 16 is a square since it is equal to 4 squared, and this is a difference of squares since we are subtracting here. As such, we can factor this expression to be x plus 4 times x minus 4. Similarly, this is a difference of squares since 4x squared is equal to 2x all squared, and 9y squared is equal to 3y all squared. So we can factor this expression to be 2x plus 3y times 2x minus 3y. Here's another difference of squares. Please note that x to the power of 6 is a square since it is equal to x cubed times x cubed. In other words, x to the power of 6 is equal to x cubed all squared. Also notice that 25 is a square since it is equal to 5 squared. Since this is a difference of squares, we can factor it to be x cubed plus 5 times x cubed minus 5. Here's another difference of squares, and we can factor it to be 7x squared y plus 1 times 7x squared y minus 1. Okay, here's one last example. Now be careful with this one. A common mistake to make here is to classify this as a difference of squares. While x squared is a square and 81 is a square, this is not a difference of squares since the two squares here are added. So we cannot factor this expression in any meaningful way other than to write it as 1 times x squared plus 81, which doesn't really help us at all. Okay, let's summarize. Be sure to watch out for expressions that are differences of squares. If you encounter one, you might want to consider factoring it to help you gain some insight into the particular problem.